Hey everyone, in this video we're going to learn how to multiply polynomials. I'm going to show you two different methods that you can use, and you can pick which one that you're more confident with. The first method that we're going to go over is the geometric model. Now this is a really great model, especially for those of you whose work kind of tends to scatter across the page, or you're the type of person that maybe misses something in a problem typically, because this is a great way to stay organized. So how this works, in this example, we have 4x minus 1 times 2x plus 3. So we're multiplying two binomials together. So I created a 2 by 2 box, right? So if I had a trinomial, I'd have a 3 by 2, right? Trinomial and a binomial. And we're going to take each term of the binomial and put it on one part of the box. So we have 4x minus 1. Notice I keep the sign with the term. Okay, so minus 1 becomes negative 1 on that column. And then we have 2x plus 3, so 2x plus 3. And now to figure out the entry inside each part of the box, we're going to multiply the two terms along the edges. So for this entry, we're going to multiply 4x times 2x. Multiply the coefficients, we get 8. Let's fix that. Let's make that look a little bit nicer. 8, and then x times x, x squared. Then we're going to have 2x times negative 1 to get this entry. We'd have negative 2x. 4x times 3, 12x. And then 3 times negative 1 is negative 3. So there are all of our products. And now what we're going to do is look to combine like terms. So 8x squared, I don't see any other term with an x squared in it. So we have 8x squared. Negative 2x, well, I also see a positive 12x. So combining those two, we'd get plus 10x. And then constant term, negative 3. It's the only constant term that I see, minus 3. So there we have the product of 4x minus 1 times 2x plus 3. Couple key things to look at. We had a binomial of degree 1 times a binomial of degree 1. Product is a trinomial of degree 2. Okay, so it doesn't necessarily have to be a trinomial, but degree 2 is a good sign that we did our multiplication correct. Next example, we're going to do the trinomial times the binomial. So we have 2x squared minus 4x plus 5 times 3x minus 1. So notice our box now, I chose to make 3 columns and then 2 rows. So we'll put the trinomial across the top. So 2x squared minus 4x plus 5, and then 3x minus 1. There's no reason you couldn't have done it the other way and made 2 columns and 3 rows. Works out the same way. Now, find the entries of each part of the box. We're going to multiply what's along the edges. So 2x squared times 3x, 6x cubed, negative 4x times 3x, negative 12x squared, 5 times 3x, 15x, 2x squared times negative 1, negative 2x squared, negative 4x times negative 1, positive 4x, positive 5 times negative 1, negative 5. And again, we go through looking to combine all of our like terms. So 6x cubed, don't see any other x cubed terms. So 6x cubed. And then we have negative 12x squared and a negative 2x squared. That's going to be negative 14x squared. 15x and 4x plus 19x. And then minus 5. So there we have the resulting polynomial when we do our multiplication. Now, we multiplied a degree 2 trinomial by a degree 1 binomial, and we got a degree 3 polynomial. Degree 2 plus degree 1 is degree 3, so good indication that we did it correctly. Okay, and hopefully we didn't make any errors in any of our smaller multiplication. Now, that brings us into method 2, which is distribution. Okay, a more direct approach to multiplying our polynomials. Now notice same two problems, okay, so we can also compare and make sure our answers are correct. And we can also more directly compare the two methods to see which we like better. So the way we do the distribution, okay, is basically, it's often referred to as double distribution. So what we do, if I want to expand it out a little bit more clearly, what we're doing is taking the 4x and we're going to distribute that into the 2x plus 3. And then we're going to take the negative 1 and distribute that into the 2x plus 3. Okay, so then we'd have distribution there, we'd have distribution there, so we'd have 8x squared plus 12x, and then plus negative 2x minus 3. Right, so now we have the addition of two polynomials, tying back into some of our past work, and then that's going to be 8x squared plus 10x minus 3. And what we can see here is these were all the terms we had in that box method, just written out in a linear fashion. Now the trinomial, okay, similar idea. Okay, so 2x squared minus 4x plus 5 times 3x minus 1. So we can do the distribution either way, but let's think of it as 2x squared times 3x minus 1, and then minus 4x times 3x minus 1, and then plus 5 times 3x minus 1. Distribute everything in. So that would be 6x cubed minus 2x squared. And then we'll have plus negative 12x squared plus 4x. And then plus 15x minus 5. Now we go to combine our like terms. So we have 6x cubed. We have negative 2x squared, negative 12x squared, so minus 14x squared. We have a 4x and a 15x, so that's plus 19x. And negative 5 is our only constant term. Now, typically, most students will wind up skipping over this first step that I wrote in each of these examples, and they'll just get straight to the distribution and get these terms in this line, okay, or above these terms right here. Okay, so if you choose distribution as the method that you prefer, that's typically what happens. You get to a point where you get comfortable and can go directly to this point. It does make it a little bit more efficient. Personally, anything with a trinomial, I prefer to work with the geometric model, and two binomials, I do think the distribution method is a little bit more efficient. Okay, so a couple practice problems. Multiply each of the following polynomial expressions. All answers should be written in standard form. Okay, so let's do this first one with the geometric model. Okay, so binomial, binomial. So we're going to create a box with 2 columns and 2 rows. So we have 5x plus 2 and x plus 7. So multiplying them out, we have 5x squared, 2x, 35x, and 14. So that means that our product is 5x squared plus 37x plus 14. Our next example, 3x minus 1 times 3x plus 1. So I'll give you an example of going directly. So 3x, let's distribute that in first. So we'd have 9x squared plus 3x. And then we'll distribute the negative 1 to each term. So we have minus 3x minus 1. Combining our like terms actually simplifies to be 0. So we're left with just 9x squared minus 1 as the product of these two binomials. Let's keep going. Practice with two trinomials now. So this is really a good example to use the geometric model. So we need to create a box with 3 columns and 3 rows. We want to make it nice and big. So there's our 3 rows. There's our 3 columns. So we have x squared plus 2x minus 5, 2x squared minus x plus 1. And now we multiply to find all our terms. So we're going to have 2x to the 4th, 4x cubed, negative 10x squared, negative x cubed, negative 2x squared, 5x, x squared, 2x minus 5. And now we have to combine all our like terms. So that's going to give us 2x to the 4th. Let's see, there's our x cubed terms. I'll circle those. X cubed terms. That's going to be plus 3x cubed. Then we have 3x squared terms. And it's really nice when they happen on the diagonal like that. It doesn't always happen. Minus 11. Oh, want that to be green. Minus 11x squared. And we have our 2x terms there. So that's plus 7x. And then our constant term of minus 5. Now our last example is an important one. It's one that students always make a mistake on. Okay, please, if you get a polynomial squared or a polynomial cubed, write it out. What do I mean by that? Write it as 2x plus 3 times 2x plus 3. I know it's really tempting to just square each part of the binomial, 4x squared plus 9, call it a day, circle your answer, and move on. But you're going to get that question wrong over and over again. And it's going to start to be frustrating. Okay, so take the extra 10 seconds to write the problem out, right? Squaring something is multiplying it by itself. Right, we talked about exponents are the condensation of repeated multiplication. And then you're setting yourself up for a really much easier problem. Or I shouldn't say that. It's not super easy, but you're going to get the right answer. Okay, so we'll do the distribution method here. So we're going to get 4x squared plus 6x. Distribute the 3. We're going to get plus 6x plus 9. Combine our like terms. 4x squared plus 12x plus 9. Okay, so there's our few practice problems. If we multiply the degree 4 polynomial by a degree 2 polynomial, what would the degree of the resulting polynomial be? And explain. Okay, so I want to give you a few seconds to think about this. Look at the past examples that we did in this video and see if you can come up with an answer for this question. Okay, don't want to keep you waiting too long, but hopefully you have an answer now. So let's start with a simple degree 4 and a simple degree 2. So that would be x to the 4th times x squared. And if we were multiplying those two polynomials together, same variable, so we're going to add their exponents, so 4 plus 2, so that would be x to the 6th power. Okay, so the degree of the product would be a degree 6. Now, even if we created more complex polynomials, right, like a trinomial times a binomial with these 2 degrees, convince yourself that we're still going to get degree 6 because all the other terms are going to have lesser degrees. Okay, we still have more multiplication to do, but that's not going to affect the degree of the polynomial. And what's our explanation here? Well, if we're multiplying two expressions with the same variable, we add the exponents. Okay, so multiplying terms with the same variable, we add the exponents.